everyone. My name is Kelly Hall. I'm a marketing coordinator here for ALS North America. I want to thank you all for joining us today for our Webinar Wednesday series. Our presenter today is Ralph Poulsen. Ralph received his Associate of Science degree in Chemical Technology along with a BS in Business Administration. He started his career as a laboratory technician for 13 years and then became a chief chemist. From there, Ralph has also been an operations manager, vice president of operations, and a CEO. He is a member of the American Chemical Society, the American Council of Independent Laboratories, and the Solid Waste Association of North America. Now, Ralph serves as the laboratory director of the ALS Tucson Laboratory. And today, he will be discussing alternative fuel testing services. During this presentation, feel free to use your chat box or the Ask a Question features to ask any questions throughout this presentation. Ralph, thank you for taking your time today to deliver this presentation. I will go ahead and turn it over to you.
Hello, everyone. I hope you can hear me. I'm all of a sudden started experiencing technical problems.
You sound great over here.
Okay, very good. Okay, so thanks for coming to the webinar Wednesday on alternative fuel testing services. I'll go over a little bit about the Tucson laboratory and then delve into what is alternative fuels and why are they tested and some of the test methods that we use. So if anyone has any questions, please feel free to raise your hand or just ask a question here. So, oops, sorry. Okay, so the history of the Tucson laboratory for ALS, we're a small lab where we have a 6,000 square foot facility. We're in the process of building a new 8,000 square foot facility. Not much gain in square footage size, but it's really going to help production. The laboratory started in the 80s as Desert Analytics, very small lab. It had just 2 or 3 people working it and doing microelemental testing for government research labs and university research labs. Tucson laboratory was acquired by Columbia Analytical in 2005 and then ALS in 2011. Since that time, I came on board in 2005 and we've added some new markets that we provide services to. Those include alternative fuels, mining related type work, environmental type work, and all of the work that we do is really specialized work. None of the other ALS laboratories perform these analyses that we do. And we have accreditation through A2LA, it's ISO 17025. Well, first of all, the importance of alternative fuels, you probably hear about this on the news all the time, but alternative fuels are really critical to gaining and reducing dependence on historical sources of energy like gas and coal and hydroelectric. One of the benefits of the alternative fuels is they were once considered a waste product, but now they're being used in a productive way. Another thing with alternative fuels is they're considered a clean, renewable energy. In the case of biomass, even though when it burns, it gives off carbon dioxide and particulates, but the new material that's replaced in the burn material is absorbing that carbon dioxide. So right now, here's a slide showing biomass to electricity, and this is a real biomass to electricity is only about 1 to 2% of the total electricity generated in the United States, but you can see the growth over the years. And it really started taking off in the late 80s, early 90s. And you can see some of the other countries around the world, Germany, China, Brazil, Japan, they're all starting to increase their generation of electricity through by burning biomass. Another way to generate electricity, and this isn't included in the biomass electrical generation. This is municipal solid waste to energy. As of 2016, there were 71 plants. Most of these electrical plants are in the Northeast and Florida, and most of them are called a mass burn plant. So they're not doing any sorting of the municipal solid waste that they get in. They have grappling hooks that just pile the waste material onto a moving conveyor belt that feeds the waste right into the furnace. In 2016, they produced 14 billion kilowatt hours of electricity. They consumed 30 million tons of solid waste. Basically, this industry was non-existent prior to 1980. It showed real rapid growth until 2000. It started to slow down, and they're starting to see an increase in growth here in the last couple of years. So what is an alternative fuel? Basically, an alternative fuel is any carbon-based material that can be used as a fuel or used to create a fuel. And a lot of the different materials, there's forestry and agricultural waste products. Hog fuel is like wood chips. It's a slash from the process of cutting trees and using the pulp, or it's used for pulp and paper. It's that waste product. There's wood chips, crop waste, other things like chicken litter, dairy farm biosolids. We've even got nutshells in to test for their heating value production. Another source of alternative fuels I mentioned earlier is municipal solid waste or industrial solid waste. And this will include, in addition to the municipal solid waste, the trash, it includes tires, manufacturing waste materials, plastics, paper, sludge. And then for the pulp and paper industry, a big one is black liquor. There's also another source that's dedicated energy crops. They're starting to become more popular. Palm oil is real popular in countries that are in the tropical zone. Little less popular right now, or less being used, is the pyrolysis oil from biomass and municipal solid waste. There's a few plants that are working on that. They're primarily experimental right now. And then we've also worked on some big projects where it was algae to jet fuel. And again, those are all pretty much experimental right now. They have had a few recent flights of commercial jets using jet fuel from an algae-based material. The industries we served, the biggest one is pulp and paper industry. They've been doing using alternative fuels for many, many years. Their process called the craft process is really good for using alternative fuels. Their primary use is to burn waste wood and other wood products for heat generation for boilers. Cement manufacturers are another one that really are starting to use a lot more alternative fuels. And a good example there is they'll use tires, and they use a whole tire, and they get two benefits from that. They get the heat value, the high BTU from the tire that's burning, and then they also get the steel that's in a tire that's used in making clinkers for the cement. Some other ones are waste energy plants. We're seeing more and more of that work. Like I said earlier, most of those plants are back in the Northeast or in Florida. The Tucson lab, we also do a lot of work with government and private research labs, and we get this work from all over the world. Most of it comes in from the USA and Canada. We see work from Mexico, South America. Our sister lab in Hong Kong sends us in municipal solid waste samples on a regular basis. So what's driving the need to test the alternative fuels? Probably there's two main drivers. The first one is like air regulations, the boiler MAC and greenhouse gas regulations. And these tests, I'll explain these later on what kind of analysis that we do for these, but they're basically looking for emissions of either metals or chlorine or mercury. And a lot of times these projects are performed in conjunction with stack testing for emissions. Another reason why we're testing alternative fuels is to determine the fuel quality, and this is to optimize the boiler and furnace performance. We're also looking at things such as what would cause fouling or slagging problems with the boiler. And again, the last one would be analytical support for research labs. We've been working with a government research group since 2005 on this, and doing pyrolysis oil generation from biomass. Okay, one of the biggest issues with alternative fuels is getting a representative sample. And this picture shows a trash pile that could technically be sampled and samples sent in and analyzed for the various fuel content. The sampling is critical in getting good quality data from these tests. And typically what we do is, say a trash sample, we get samples in 5-gallon buckets, and then we go through a series of grinding and splitting and regrinding of the samples. So the next few slides is going to kind of go over that. Wood chips and hog fuel, they're a lot more homogeneous, and we don't quite have the sampling program or problems that we do with municipal solid waste, but it still requires that we prep fairly large samples and get those down to a very fine grain size so that we can analyze them. So this would be a typical sample that we get in for municipal solid waste, and you can see it's a mixture of paper and plastics, and there could be food waste in there, chicken bones, whatever. So it's very heterogeneous, and it requires a lot of effort and time to prep these types of samples so that they give high quality data. Here's one of the knife mills that we use in the prep process. This is a German mill. It's called a P25 knife mill, very heavy duty. This mill is very expensive. It's a $30,000 to $35,000 piece of equipment, and you can see the rotary with serrated knife edges on the rotating rotor right there. So what we'll do is we'll take the samples, and if they're large pieces, we'll have to pre-cut them by hand, or sometimes we'll run them through a hammer mill. Samples that have plastic in them are previously, we pre-freeze those with liquid nitrogen, and a lot of times we'll run those through a hammer mill to get the material reduced in size to about 10 millimeter. And this is this picture here, it shows paper and plastic film sample that has gone through the coarse grind process. Those are less than 10 millimeter. Here's a close-up of that material. And you can see the plastic in there. You can see paper. So it's very heterogeneous. So the next step that we do after we get the coarse grind is we go through a fine grind process, and we use another knife mill. This is the same manufacturer as the first one. It's a P19 mill, and this will take the material down to 1 to 2 millimeter in size. So here's a picture of, this is primarily that paper, but there's a lot of plastic film in there, and you can see how finely that's ground. Even though it's ground fine, that you can still see that there's some heterogeneity in the sample. Here's a plastic sample that this was all plastic, hard plastics that was ground down to 1 millimeter. And you can see, again, the heterogeneity of the sample. So the problems that the heterogeneity creates is that when, say, we're doing a chlorine test and you have PVC pipe in there, it only takes 1 or 2 pieces of PVC pipe to really throw off your chlorine results. So we do a lot of duplicate analysis, repetitive analysis to make sure that the data is good and correct. Hog fuel or wood chips, they're the easiest and best to grind. Here's an example of a hog fuel that's less than 1 millimeter, and it's ready for analysis. So the analytical process, there's 2 basic areas that we're testing the samples, and one of them is for the fuel quality, and this information is needed to determine how well the material is going to act as a fuel, the BTU values, the moisture content, the ash content, and then we do some other tests that help determine if the ash is going to be a sticky ash or have a low fusibility. So the first test and the primary test we do is heating value, and this is performed on a bomb calorimeter. The old systems weren't automated like this. This is fully automated, and it very, very accurate. Typically, our QC results on this instrument are 99 to 101% recovery. They're very, very accurate. The next instrument that we use is thermal gravimetric analyzer. And this unit is specifically for fuels. And from this instrument, we can do proximate and other gravimetric analysis. Proximate is a term that includes moisture, volatile matter, fixed carbon, and ash. And then some of the other analysis that we do is loss on drying. We can also use this instrument to determine free moisture, inherent moisture, different types of loss on ignition at different temperatures. So it's a very versatile instrument. Basically, it works on the principle of you have the small crucibles in there that we load up with 1 gram. The crucibles are pre-weighed by the instrument. We take the crucible out, add the sample, replace it back into the furnace. And there's actually a balance inside that furnace that will weigh each of those crucibles in a repetitive circulating motion. So each sample will be weighed maybe 100 times during one of the analytical processes. Another test that we do for fuel quality is called an ultimate analysis. And the ultimate is carbon, hydrogen, nitrogen, and then it also includes sulfur. And then sometimes we'll do carbon forms, which would be inorganic or organic forms of carbon. You can see the different methods that we use. These are all ASTM methods right here. We do also perform some TAPI methods. So the next type of analysis that we typically perform on alternative fuels is for environmental analysis that are performed following various regulations. The main one that we follow that's being followed for that work is Boiler MAC regulations. And Boiler MAC is a series of regulations that require users of different fuel sources to test for mercury, chlorine, and what are called select metals, total select metals. And I'm going to go through and show you each of the instruments that we use on those tests and the methods that the test is being performed under. So for mercury analysis, we have it's a Nippon 3000 mercury analyzer. It's made in Japan, and this is different than your normal environmental mercury analyzer. The principle that it works under is high temperature combustion at 950 degrees. The gases are trapped on a gold amalgamation tube, and then that tube is heated up to release the mercury, and the mercury measurement is done by atomic absorption. It's a very, very sensitive instrument. On a solid sample, that say we run 20 to 30 milligrams of material, we have a reporting limit of 1 ppb. What makes this method so good for the type of samples that we're analyzing is that the normal environmental methods are not able to get full recovery of the mercury that may be tied up in the, say, in the plastic or the rubber matrix of the sample. And so they're going to result in a low recovery of your mercury. Those methods include EPA 7472 and 1631. Now for wood chips and sludge and other easily digested samples, those methods work real good. But any samples that have plastics or rubber in them, the mercury really needs to be done by the combustion method. Another test that we do for the Boiler MAC regulations is total halogens and primarily total chlorine. This is an older method that involves combusting the sample in an oxygen bomb. The sample's weighed out. There's a small amount of scrubber solution put inside the bomb. The bomb is closed up, sealed, and then it's charged with 30 atmospheres of oxygen. And there's you can't really see it very well, but there's a fuse wire that goes from the two electrodes into the sample. And the sample's combusted, and any chlorine or halogens in that sample are going to turn into a gaseous form. They're going to be absorbed by the scrubber solution. And then after set time, we take that, release the pressure, collect the scrubber solution, and then analyze it by ion chromatography. And we can get reporting limits down into the 10 to 50 ppm range. I'm currently looking at an automated system for this, which involves a pyrolysis furnace, and then we'll have an automatic scrubber solution system that is analyzed by IC. Total select metals is the third group of analysis that are performed on alternative fuel samples for the Boiler MAC regs. And those metals, you can see them on the graph there. These are typically performed using environmental techniques. The digestion is either 3050 or 3051 microwave. Sometimes the samples will require ashing and then followed by an acid digestion to solubilize the metals. Another, and then analysis, those digestates are analyzed by ICP or ICP-MS, 6010C or 6020A. Some other tests that we can perform on the samples are actual fuel analysis for heavy metals. And those typically involve doing a total dissolution of the ash material using HF, nitric acid, hydrochloric acid with a microwave digestion system. The microwave is shown in the picture there. And the metals that we do for this, for these methods, they're called major, minor, and trace metals in ash. And analysis is by ICP OES. There's another type of material or group of regulations that alternative fuels fall under, and that's called the non-hazardous secondary materials. And they're basically solid waste that's burned as an alternative fuel, or in the case of like cement manufacturers, it's burned as a fuel and it's used in ingredients in the process of making cement. This is primarily directed at cement manufacturers or really any manufacturing firm that's using solid waste, non-hazardous solid waste as a fuel to heat boilers or to generate electricity. The samples can be anything that burns that is non-hazardous. And over the years, we have gotten some of the strangest samples. We've gotten bags of money, shredded money. We've gotten toilet seats. There was a cement manufacturer that was going to receive thousands of toilet seats. I don't know where they came from, but they wanted that tested, and other weird things like that. The preparation process on these, it's really difficult sometimes, and it's very time consuming on some of these unique samples. And typically most of them will require cryogenic grinding, which means that we first freeze the sample with liquid nitrogen before we grind it. For the fuel quality analysis, the standard fuel methods work very well with these types of samples. There's also, for the non-hazardous secondary materials, there's typically a set of environmental analysis are required. And those include volatile organic compounds by GCMS, semi-volatiles by GCMS, PCBs, dioxins. There's an expanded list of metals for both total and TCLP. And then we also do the total organic halogens. It's the same as the chlorine test that we use for the fuel. And then also total hydrocarbons. And this list can vary depending on the material that's being used as a non-hazardous secondary material. It also depends on the matrix, what that fuel or what that material is made of. So as a recap, the alternative fuel testing market is really pretty small. It's specialized. There's only a few labs that perform these types of tests. They're usually small labs. Like I said earlier, the ALS Tucson lab is, we're the smallest of the ALS environmental labs in the USA. We have about 12 to 15 people working. So they're very specialized. It's not a big market. The market is seeing modest growth over the years, and that kind of goes in line with increased electrical generation from both biomass and municipal solid waste. The instruments that we use, they're basically the same that are found in coal testing laboratories. The biggest difference is the sample preparation equipment that we get. They're highly specialized, they're very expensive, uh, and again, the sample prep process on a lot of these samples is highly involved, and it really is critical in obtaining accurate and precise data. We spend a lot of time on prep. Sometimes it's more than what the actual analysis is, both in time and cost. So that's basically the information on alternative fuel testing. I just want to close to let everyone know that Tucson, the Tucson laboratory is in the process of moving into a new facility. This is a picture of the building, and we should have that done in January of next year. Thank you for your time, and please contact me if you have any questions.
Thank you, Ralph. Yes, we will go ahead and open it up for questions. Participants, you can feel free to use the raise your hand feature, or you can just simply write a question in the question box, and we can go ahead and ask Ralph those questions. While we're waiting on any questions to come in, I do want to thank everyone for attending this webinar Wednesday today. We do record these webinars, and we will be posting this on our YouTube channel as well as our ALS website. On our website, you will find a wide range of video resources and past webinar Wednesday presentations. We also have a LinkedIn page. You can feel free to follow us there. We also post future webinar Wednesday presentations there as well. We'll go ahead and give it one more minute for any questions that may want to come in. All right. Well, we don't have any questions coming in, Ralph. If you want to show your email one last time, participants, y'all can
Oh,
email Ralph if you have any specific questions. And again, thank you to everyone for attending today, and enjoy the rest of your week. Thank you, Ralph.
okay. Thank you, everyone, for attending.